Good morning, everyone. All right, friends, welcome back. And now I have Klaus Aschenbrenner with me. Thank you very much for joining us. Friends, this session is about myths and misconceptions about locking and blocking in SQL Server. Thank you, Klaus. Over to you.
Thank you. So, thanks. Good morning, everyone. In my time zone in Europe, in Vienna, it's 8:30 in the morning. So a little bit early for me because normally I'm sleeping a little bit longer. But today I just woke up for you to talk now a whole hour about myths and misconceptions about locking and blocking in SQL Server. As you have already heard, my name is Klaus Aschenbrenner. I'm based in Vienna in Austria, and I provide with my company SQL Passion, SQL Server Consultancy and Training Services across Europe. I'm more or less specialized in the relational engine of SQL Server. So my main topics are performance tuning, performance troubleshooting, high availability stuff, and all those things. And I don't have that much idea about business intelligence, machine learning, data warehousing, and all that stuff. So more or less, I'm just concentrated on the relational engine of SQL Server. I'm also a Microsoft Certified Master for SQL Server, which is the highest technical certification that you can achieve on SQL Server. I have also written the book Pro SQL Server 2008 Service Broker. So Service Broker is an asynchronous messaging framework that Microsoft first introduced back with SQL Server 2005. It's already a very, very long time ago. And with Service Broker, you are able to write message-based asynchronous database applications. You can also follow me on Twitter, and you can find more information about my person, my services that I'm offering on my website, sqlpassion.at, where I also regularly blog about SQL Server and other IT-related stuff. Okay, so let's talk now about the agenda for the next 60 minutes. More or less, I just want to give you a brief overview about some myths and misconceptions around locking and blocking in SQL Server. So I assume that you have already a basic understanding about locking and blocking in SQL Server. So you should be familiar with shared locks, which are acquired when we're reading records. And you should be also familiar with exclusive locks that SQL Server acquires as soon as we insert a record, when we change a record, or when we delete a record. Those are just the prerequisites. In the first step, I want to talk about the famous no-lock query hint, and I just want to show you some specific example where queries with the no-lock query hint can also block. Just think about that one. Then we will continue our discussion, and I want to talk about the isolation level read committed. In that part, I want to show you an example where the isolation level read committed behaves as the isolation level repeatable read. Means in that case, SQL Server just will hold shared locks till the end of our transaction. So more or less, SQL Server is doing in the isolation level read committed the same thing as in the isolation level read committed. Afterwards, I want to talk about lock escalations, which are also very, very important for SQL Server from a performance perspective, because lock escalations are improving the scalability of the relational engine of SQL Server. But on the other hand, lock escalations are also degrading our performance, because instead of locking on individual rows, SQL Server will just escalate those individual row level locks to one lock on the table level. So maybe a shared lock or an exclusive lock when you're changing data. Means in that case, your whole table is afterwards locked and nobody else can access that table for reading or writing anymore. And in that section, I just want to show you an example if lock escalations are always happening in SQL Server. And finally, at the end, I want to talk about online index operations in SQL Server. They were introduced in the Enterprise edition of SQL Server, so the expensive edition. because you have to pay a lot of money for it. And online operations are not really online operations in SQL Server. Means when you're online rebuilding or creating an index, from a marketing perspective, Microsoft is telling us that we can do that concurrently with our normal workload. But in reality, online operations are not really online because they can also block in SQL Server. Means when you're rebuilding your clustered or non-clustered indexes, it's quite easy that you are also getting into blocking situations. So online operations in the Enterprise Edition are not really online operations because they can also block quite easily. So that's the agenda for the next hour. Let's start now by talking about the famous query hint, no lock. I think every one of us knows about that query hint, and to be honest, every one of us has already used that query hint very, very often or quite frequently. Even when I'm performing consulting engagements, when I'm looking into various databases across the world, almost everywhere, I see the query hint no lock. No lock is great because it just improves our performance. But on the other hand, the side effect is, as the name implies, no lock, SQL Server doesn't lock our records anymore when we are reading records. So the no lock query hint just applies for select statements when we are reading records, when we are retrieving records from our database. Normally, without the no lock query hint, SQL Server acquires a shared lock when we read a record. And when we now use the query hint no lock, SQL Server don't acquire that shared lock anymore. Means when someone else has concurrently an exclusive lock on that row that we want to read, we can just read that record because we don't acquire a shared lock. Normally, without the no lock query hint, SQL Server acquires a shared lock. The shared lock is incompatible with the exclusive lock, means in that case, your select statement will just block. It's a traditional blocking situation in SQL Server. And you can overcome that blocking situation by using the query hint no lock. You're not acquiring a shared lock during the reading of a record anymore. But on the other hand, when you don't acquire a shared lock, SQL Server can return you uncommitted data. Because when the other session is currently changing that record, the other session holds an exclusive lock. But when you afterwards roll back that change that you have done, the other session has already read and retrieved that data and maybe further processed. So that's a real drawback of that approach. So normally, in production databases for queries which have to be accurate, which is normally the case, you should never ever use the no lock query hint. When you don't need a consistent result, maybe for a report and you want to know how many average sales I have done today or this week or that month, maybe the query hint with no lock is a good idea because you are not relying on accurate data. But when you need precise, accurate, committed data, the no lock query hint is a really, really bad idea. But using no lock doesn't mean that your queries are not blocking anymore. There are also some circumstances where even queries with the no lock query hint can block. So let's have a look on a concrete example of that one. So we are here now in SQL Server Management Studio. And in the first step, I'm just creating here a new database. Quite simple. In the next step, let's just create a simple table. So again, my table definitions are quite simple, just 3 columns, integer values, and then we are just inserting in a while loop 1000 rows. Takes not that much time. So we have here now as a preparation a simple table, 1000 records, 3 columns per each record. And what I'm doing now, I'm beginning now an explicit transaction. And then imagine in that transaction, we're performing database changes. Maybe that transaction is part of a data migration script that you are deploying into production. Means maybe we are making now some schema changes. So let's do an alter table. We're just changing that table. We have currently 3 columns, and we just add a 4th additional column to that table. We have here an ongoing transaction, means SQL Server has now locked that table somehow. I will show you later which lock SQL Server is using here. But very, very important, we have here an ongoing transaction. That transaction isn't yet committed, means the locks that we have acquired in that transaction are still held by SQL Server. And now imagine we have a second transaction, and what we are doing here, we are going into that database, and now we are just reading from that table. Perfect. Not really. My SQL Server is so slow, 1,000 records. That query is executing and executing and executing. Nothing happens. No idea why. Normally, when I have queries which are slow, I'm just always telling, let's have a look on the execution plan, because the query is just a logical construct, and with the logical construct, you have no idea what happens on the physical level. So let's have a look on the estimated execution plan. So I click here, display estimated execution plan. It's slow. No idea. It's slow. Means SQL Server tries to compile a physical execution plan, the estimated one, for the query optimizer. Nothing happens. Strange. Let's cancel that one. Let's try now that turbo booster. No luck. So we do here with no luck. Let's run that query again. It's still slow. So as you can see, even a query with no luck blocks. The question is why? Let's go back to our first transaction, which is altering here our table. When you're altering a table, SQL Server acquires a so-called schema modification lock on that table. We can see that lock in the lock manager through the dynamic management view system twin locks. I'm restricting here on my current session ID 58. And as you can see on the object level is the table level. In the case of SQL Server, you have here the object ID. We have here a so-called schema modification lock. This is the most restrictive lock in SQL Server. It's even more restrictive as an exclusive lock. So we have here that schema modification lock, which is granted with an ongoing transaction. It's not yet finished. So we are still holding that restrictive schema modification lock. And now let's have a look back on the other query. When you want to run a query, in the first step, the query optimizer has to compile you a physical execution plan. And for compiling a physical execution plan, the query optimizer acquires a so-called schema stability lock. And that schema stability lock is incompatible with the schema modification lock that our first transaction is holding. That's also the reason why we can't display or retrieve the estimated execution plan from SQL Server. Because for retrieving the estimated execution plan, the query optimizer kicks in to generate that estimated plan. And the query optimizer, as I've said, needs the schema stability lock, and both locks are just incompatible. So we have here a session ID of 62. Let's restrict on session ID 62. Let's look again into the lock manager. As you can see on the object level, we have here now a schema stability lock on which we are currently waiting. So when we restrict here on that object ID, which is in the case of the lock manager here, the resource associated entity ID column, you can see that we have on the same object, in our case on that table, test table, we have successfully acquired a schema modification log, and another session ID 62, is currently waiting on a schema stability log. So no log, the query hint no log, or even the isolation level read uncommitted is no guarantee for you that your queries are not blocking. Even with no log, your query can block because the query optimizer needs to acquire in the first step your schema stability log. Just think about it. And as you can see, when we are now finishing our first transaction, by doing a rollback or even commit, depending on the outcome of that transaction, that session releases the schema modification log. And finally, the other session, which is currently still executing, acquires the schema stability log. So as you can see, we have released that log, transaction rolled back, and finally, we can acquire the schema stability log, which is needed for the query optimizer to compile the estimated execution plan. That estimated execution plan is handed over to the query executor in SQL Server. And finally, the execution plan is executed and the result of that execution plan is returned back to us. So that's a nice example which proves that the no log query hint is no guarantee that you have no blocking situations in SQL Server. So just think about it. I have seen that very, very often, especially when you are deploying database changes, when you're altering tables and so on, that you are getting into blocking situations in combination with schema stability logs, which are normally acquired by the query optimizer. So let's go back to PowerPoint. Let's talk now about so-called hold locks in SQL Server. SQL Server, we have various isolation levels. With uncommitted, as the name implies, returns you uncommitted data, more or less the same thing as we have done with the no log query hint. Then we have the isolation level read committed, which is the default isolation level. And then read committed, SQL Server acquires shared logs for reading records during that time when we read and process that row in the execution plan. Means as soon as you have read that row from your table, from your index, that shared log is released. Therefore, you have in read committed no so-called read stability. When you're reading the same row over and over again in your transaction, that row can change because you are releasing that shared log as soon as you have read that row once in your transaction. If you want to have a so-called read stability, you can use the isolation level repeatable reads. Repeatable read. Repeatable read, as the name implies, gives you so-called repeatable reads. Means when you're reading a row multiple times within your transaction, you're getting the same row version over and over again. Internally, it's quite easy to achieve that result. As soon as you're reading a row, you acquire that shared log, but you're not releasing that shared log anymore. You're only releasing that shared log at the end of your transaction. Means you're making that row with that shared log read only. Everyone else that would change that row have to acquire an exclusive log. And again, the exclusive log is incompatible with the shared log. So in that case, the writer blocks the reader. That's the idea of the isolation level repeatable read. It gives you a more consistent result. So you have a better data consistency because row versions can't change in a transaction anymore. But on the other hand, you have less throughput, less performance because you're holding those shared logs much longer till the end of your transaction. So that's the idea of the isolation level repeatable read. And normally, in the isolation level read committed, those shared logs are immediately released when you have processed that row. Therefore, other transactions can change that row during your read transaction. And now I want to show you some concrete example where even SQL Server can hold shared logs in the default isolation level of read committed till the end of your transaction. Means in that case, SQL Server behaves the same as in the isolation level repeatable read. Just think about it. You're using the default isolation level read committed, but under some circumstances, SQL Server will hold your shared logs till the end of your transaction. Means it gives you a better data consistency because you have a read stability. But on the other hand, you have less throughput, less performance because SQL Server is just locking more aggressively. Just think about it. And that specific scenario happens when you have in your execution plan so-called blocking operators between your data retrieval operators and an update operator. A blocking operator in SQL Server can be a sort operator, can be hash operations like a hash aggregate, hash join operator. And I was able to construct an example of that specific problem in combination with LOB data types. LOB data types were introduced a very, very long time ago in SQL Server, back with SQL Server 2005, so more than 15, 16 years ago. And an LOB data type can store up to 2 gigabytes of data. So it's just blob data within your database. And when you are referencing in your select statement a column which is an LOB data type, like a varchar max, var binary max, and all those data types, then your select query will hold its shared logs till the end of your transaction. Means, in that case, the isolation level read committed behaves as the isolation level repeatable read. So let's have a look on that one. So I'm creating here again a new database, and I create again a simple table. As you can see now in that test table, I'm using here an LOB data type, varchar max. Means in that column, I can store up to 2 gigabytes of data per each record. Just think about it. So internally, SQL Server is using here a specialized construct to structure that data and everything. But in that column, we can store for every record up to 2 gigabytes of data. So maybe you are storing here image data, documents, whatever you want. So that functionality provides you SQL Server since SQL Server 2005. So already a very long time ago. Let's insert here now some records. Of course, I'm not stupid. I'm not inserting here 2 gigabytes per each column. I'm just inserting here a few bytes. So not that much data that we have now in that table. But very important to know, column 3 is our LOB data type. In our case, a varchar max column. Okay, let's begin the new transaction. And what I'm doing here as a test setup is that I'm just locking the first row in that table. Sorry, the last row, ID 3. So we are locking just the third row in that table with an exclusive lock. Means when we look into the lock manager, system logs, request session ID equals our session ID of 56. You can see that we have here on the key level. A key level implies that we are working here with a clustered or non-clustered index, that we have here on that key in our clustered index an exclusive lock, which is granted. When we look back to our table definition, you can see that I have used the primary key constraint, and by default, the primary key constraint is enforced in the background with a unique clustered index. So every time when you specify here the primary key constraint, you are getting in the background a unique clustered index. And in that unique clustered index, we have now exclusively locked the third record. This is just a test setup. Means every time when we are now reading from that table, we are getting, of course, into a blocking situation. As I've said previously, when you read from a table, SQL Server has to acquire a shared lock, and that shared lock for reading is, of course, incompatible with the exclusive lock that we have acquired here with the update statement. So let's go back now to a different session. Let's go into that database. And now let's try to read from that table. Of course, that statement is blocking. As I've said, we have on the third row an exclusive lock. But with that blocking situation, I want to show you now what or on what record SQL Server has acquired shared locks. As you can see, I'm referencing here column 2. When we go back to our table definition, column 2 is an integer column. So we are not talking here about an LOB data type. We have here a session ID of 57. So let's restrict on session ID 57. And as you can see, I'm just concentrating currently on the key level. So on the record level, we are just waiting on a shared lock on one row. Means during that select statement, we have read the first row. We have acquired on the first row a shared lock. We have read that row. After we have read that row, we have released that shared lock. Then we have acquired a shared lock on the second row. We have returned or processed that row through the execution run. Afterwards, we have released that shared lock. And finally, we are trying to acquire a shared lock on the third row. But the third row is currently locked with an exclusive lock through that update statement, means that shared lock, the acquiring of that shared lock, just has to wait. So this is a traditional blocking situation in the isolation level read committed. Nothing special about it, just a traditional behavior. Everyone would expect that here. Of course, when we use here the query hint with no lock, as we have done it previously, that query would return us immediately a result. Because with no lock just means we are not acquiring shared locks. So far, so good. Let's continue and let's run another statement. More or less, it's the same statement, but the difference in that statement is that I'm now referencing in my select statement the third column. And as you know from previous, the third column is a varchar max, an LOP data type. Just think about it. It can store up to 2 GB of data. And in addition, I'm doing an order by. The order by implies here that we have in the execution plan a sort operator. As I've said previously, a sort operator is a blocking operator in the execution plan. It must consume the whole input from your index, then it sorts your data and returns you the sorted output. So it's just a blocking operator in the execution plan. It's not a pass through operator which just passes rows through it. It's a blocking operator. It must consume the whole input. Then it is doing something with that consumed input, like producing a sorted output. And finally, it returns that sorted output. The same implies, for example, to a hash operator, like a hash join or a hash aggregate operator. Those operators are also blocking operators in your execution plan. Let's have a look on that one. Let's have a look on the estimated plan. Whoops, yeah, it works, of course, this time. So as you can see, we have our clustered index scan followed by a blocking operator. Means we are reading all the rows from that clustered index. In our case, we are reading those 3 rows. We are passing those rows into the sort operator. Then the sort operator is sorting that rows. And after the sort returns you some rows. Because maybe the last row that we are getting from that clustered index is the first row that the sort operator must return. So that's the reason why we have here blocking operator. And in that query, we have now that blocking operator in combination with an LOB data type. Just think about it. So we are just combining here a few things. And as soon as you have that combination, LOB data type in combination with a blocking operator in the execution plan, SQL Server doesn't release those shared logs anymore as soon as we have processed those rows. Those shared logs are now held till the end of your transaction. And this is quite easy to prove. Let's run that query again. Of course, that query is blocking. And now let's have a look into the log manager. As we know from previous, we had just one key log on which we were waiting on. That was the last row in our clustered index. Now let's look into the log manager again. And as you can see, the output has changed completely. We have not one key log anymore. No, we have 3 key logs. Just think about it. We have 3 rows in that clustered index, and all 3 rows are currently logged with a shared log. We were able to acquire the shared log on the first and second row. Makes sense because on the first and second row, we don't have any incompatible logs. And on the third row, we have our incompatible exclusive log that we have acquired here through the update statement, means we are currently waiting here. Just think about it. That's bad because the other 2 rows, the first and second row, they are currently still locked with a shared log. Means your read transaction behaves as when you're running that transaction in the isolation level repeatable read. Means those rows, all those rows in that table are currently read only. Holding a shared log till the end of the transaction just means that you are making those rows read only. Everyone else, every other transaction that wants to acquire an exclusive log, of course, has to wait. And therefore, as an outcome, you have a read stability. It doesn't matter how often we are reading those rows in that session, we are always getting back the same result. That's the idea of a read stability. But normally you are getting that read stability only in the isolation level repeatable read. You want to have repeatable reads. You want to have a read stability. But here we are also getting that read stability in the isolation level read committed in our default isolation level. Just think about it. And we only get it because we are referencing an LOB data type in an execution plan which has a blocking operator like a sort operator. And this, of course, degrades your performance, your concurrency, because you are holding those shared logs till the end of the transaction. And therefore, there are more possibilities to have blocking situations within your workload. Let's stop that query. It doesn't get better. It's the same here. I have another query. In my select list, I'm just referencing column 2, our integer column, but I'm just checking if we have a not null value in column 3. And again, column 3 is our LOB data type. And you have here, again, the same behavior. When we look again into the log manager, you can see we have again our 3 key logs. 2 key logs on the first and second row were acquired successfully. request status granted, but we have to wait on the third row because we have the incompatible exclusive lock. So this can be a huge problem. And even when we look here in the execution plan, estimated one, it's even a crazy execution plan. Just think you have an LOB data type and you just want to know if you have some data in that column. When we look at the execution plan, SQL Server is more or less doing terrible things. We are scanning our whole clustered index. So more or less, we are reading the whole table from our slow storage subsystem into the buffer pool. And then we have a filter operator. Means a filter operator just makes a row by row comparison and evaluates that filter predicate. If column 3 is not null, if yes, that column or that row is returned as a result, otherwise that row is discarded. Means you're reading your whole table just to know if you have some not null values in your LOB data type column. So this is also very, very bad. And the bad thing is an LOB data type column, of course, can't be indexed because you have some limitations with non-clustered indexes, how large your key column can be. And trust me, a 2 GB column can't be indexed. So this is another big problem that you have here with that query, that you are getting an explicit filter operator in your execution plan. Means more or less you are reading the whole table and maybe you are just discarding almost everything from that read operation. So that's another problem that you have here. But very, very important to know, as soon as you have LOB data types in your query in combination with some blocking operators in an execution plan, SQL Server will hold your shared logs till the end of your transaction. So in that case, SQL Server behaves as in the isolation level repeatable read. So just be aware of that fact. So let's make sure to roll back all my transactions. Otherwise, I have later some problems during my cleaning up. So let's go back to PowerPoint. Let's talk now about lock escalations. As we have seen in the last example, SQL Server can acquire a lot of different locks. We have seen that SQL Server by default acquires locks on the record level. So the key locks, the shared locks that we have seen so far, those locks were acquired on the row level. The row level can be a row in an index, clustered index, non-clustered index. SQL Server can also acquire locks on a heap table. Those are so-called row identifier locks. And in addition, SQL Server also acquires locks on other levels. Every row in SQL Server belongs to a page. A page is a storage unit of 8 kilobytes that we are storing physically on our disk, which is loaded into the buffer pool, so in memory. So those pages must be locked by SQL Server, so they must be protected somehow. And finally, SQL Server also acquires locks on the table level. The problem is now, the more rows you have in a table, the more row level locks you need in SQL Server. And every lock takes in SQL Server, I think, 96 bytes. 96 bytes, not that much these days anymore. Yesterday, for example, I have done some image processing with a picture, an astrophotography picture with a few gigabytes of data. So 96 bytes today is almost nothing for me. But imagine you are dealing with tables where you have millions, maybe billions of rows, and SQL Server has to store a lock for every record. SQL Server stores those locks in the lock manager that we have seen previously through the dynamic management view system twin logs. But the lock manager is just stored in memory. So in RAM means all those locks that you're holding, they need main memory. Just think about it. Therefore, it's quite inconvenient to just perform a row level locking, because at some point in time that row level locking is not efficient anymore. The more locks you're holding in the lock manager, the more inefficient the lock manager gets, because you also have to find those locks and everything. You have to check lock compatibility matrices and everything, and you need a lot of main memory for all those locks. And therefore, SQL Server implements a so-called lock escalation. So instead of locking individual rows, SQL Server escalates your individual row level locks to one table lock. Just think about it. So instead of locking individual rows with shared locks during reading your records, SQL Server acquires just a shared lock on the table level. Holding a shared lock on the table level means you have a table which is read-only. Nobody else can change that table anymore, because for changing data, you need an exclusive lock. The exclusive lock is incompatible with the shared lock on the table level. Bad, but it gets even worse. Imagine you are escalating individual exclusive locks from a row level to a table level. In that case, you have on your whole table an exclusive lock. And then it's more or less game over. Nobody else can read and write to that table anymore. It's more or less the schema modification lock that we have seen earlier. Well, the query optimizer can still compile an execution plan, but you can't access that table in any way from other sessions anymore. Not for reading, not for writing. So in that case, lock escalations are not really good, because they are degrading your performance, but they are improving the performance and the scalability of the lock manager itself. And lock escalations are happening in SQL Server when you have, on the row level, more than 5,000 individual locks. So imagine you're reading in the isolation level repeatable read, where you're holding your shared locks till the end of the transaction, more than 5,000 rows. SQL Server performs a lock escalation to the table level. Imagine you have a transaction and that transaction changes or deletes more than 5,000 rows in a table. I mean, 5,000, it's nothing these days. What are 5,000 rows? As soon as you're changing or deleting 5,000 rows from a table, SQL Server escalates those individual exclusive locks to one exclusive lock on the table level. Your whole table is exclusively locked. Imagine you have millions, billions of rows in that table. You can't access any row for reading and writing anymore. Just think about it. This really, really hurts your performance. But a lock escalation itself is just a performance optimization by SQL Server. From a technical perspective, we don't need lock escalations. It just improves the scalability of the lock manager itself. And now I want to prove you that point, because lock escalations are not happening always. They are only happening when it's possible. So as soon as SQL Server sees that a lock escalation would lead into a blocking situation, means that your lock escalation would block, SQL Server doesn't perform that lock escalation. This would be crazy. So let's have a look on that one. It would be terrible to have a blocking lock escalation, because that would be against the concept of a lock escalation. The lock escalation just wants to improve the performance of the lock manager. So let's have a look on that one. I begin here again in my AdventureWorks database a transaction, and I'm just locking the last record of the person table in that table. In my case, it's the business entity ID of 2777. So this is again just a setup. I just want to have an exclusive lock on the last row of the clustered index of the person table. So what we are doing now is the following. Let's take that query here. Let's go back to a different session and let's begin a transaction. And what I'm doing now, I'm reading from that person table 6,000 rows with the top operator, and with the query hint hold lock, I'm just telling SQL Server that I want to hold those shared logs till the end of the transaction. Means in that case, that select statement behaves as with the isolation level repeatable read. So we just want to hold those logs. Means we acquire more than 5,000 shared logs on that table, and then SQL Server will try to perform the log escalation. Means SQL Server want to escalate those individual shared logs to one shared log on the table level. But that escalation doesn't work because we have on one row in that table already an exclusive log. Means you can't acquire a shared log on the table level because that's not possible. Someone else has exclusively logged one row in that table, and you want to make that table read-only, but you have an ongoing data modification. This doesn't work. Means in that case, your log escalation would block, but that's not the reason. A log escalation would not block. Means in that case, just no log escalation will happen. Let's go to SQL Server Profiler or SQL Server Extended Events. Doesn't matter how you do it. You can even do it with extended events. I'm doing now today the crazy route. Let's go to Profiler so that people can complain about me. I like that when people talk about me. So let's use today Profiler. And I'm capturing here under logs the event log escalation. As I've said, you can do the same thing with extended events, which is also the preferred way. But let's do today terrible things. I'm just in the mud of it. So let's begin a transaction and let's read those 6,000 rows. We're getting back a result. Perfect. Let's check Profiler. No log escalation has happened. Let's look into the log manager. We have here session ID of 58. And as you can see, we have here hundreds, thousands of key level logs. So that's also the proof that the log escalation didn't happen. So a log escalation only happens in SQL Server when it's possible. So a log escalation would never ever block in SQL Server. This wouldn't make in any way sense. Of course, as I've said previously, every log here needs 96 bytes of main memory. So you're storing a lot of stuff in main memory. Just think about it. So that's the side effect. Let's roll that one back. And let's roll back that one. Both transactions are rolled back. Means we have now released that exclusive log on the table person. And now we are running that statement with the hold log query hint again. When we go to Profiler, you see a log escalation has happened now. Because now it's possible, because you have in that table no incompatible log to the shared log that you want to acquire on the table level. So when we look again into the log manager, you can see now instead of more than 7,000 logs, we just have 5 logs. Just think about it, 5 logs. And you can see on the object level, which is the table level, you have now successfully acquired the shared log. So that's the proof that the log escalation will only happen when it's possible from the current locking situation. But the log escalation doesn't happen always. It would be really, really terrible to perform a log escalation and that log escalation will just block. That would be against the concept of a log escalation. Just think about it. Let's close again Profiler. So this is also very important to know that log escalations are only happening when it's possible to do that log escalation without any blocking situation. Otherwise, it would be terrible. Okay, and now let's talk at the very end about one of my favorite features in SQL Server, online index operations. Oh my God. I think they were introduced, I don't know in which edition anymore, doesn't matter. Online index operations are not really online in SQL Server. The marketing department of Microsoft is telling us, or marketing department of SQL Server is telling us, online operations are great because they are only part of the enterprise edition, the expensive edition, so you have to pay a lot of money for it, and you can do that as online operations. Means you have a concurrent read and write activity on your table, and during that concurrent read and write activity, you are able to create indexes, clustered, non-clustered indexes. You are able to rebuild those indexes without influencing your user workload. That sounds great. So a lot of people are investing in the enterprise edition, and afterwards, when they try to run online operations, they're really scared because even online operations can block in SQL Server. Because when you run online index operations in SQL Server still has to acquire locks. The crazy thing is, at the very beginning of your online index operation, SQL Server acquires a shared lock. As we already know now, a shared lock is incompatible with an exclusive lock. And at the very end of your online index operation, SQL Server acquires a schema modification lock. We've already talked about the schema modification lock at the beginning when I have talked about the no lock query hand, and I have told you that a schema modification lock is the most restrictive lock in SQL Server. Even the query optimizer can't compile an execution plan. And that lock type is acquired during your online index operation. Just think about it. Microsoft has fixed that problem in a Microsoft way. Beginning with SQL Server 2014, Microsoft has introduced so-called lock priorities. Means when you are running your online index operation, you can define how you want to deal with those blocking situations. You can decide to roll back your transaction or to roll back the blocking transaction. But it's not really a fix to that problem. Those logs are needed from a technical perspective. So let's have a look on that one. Let's go back to SQL Server. And now let's work with online index operations. So let's create a new database. I create again a very simple table. As you can see, 3 columns. I create on the first column a unique clustered index. I could also have done that with the primary key constraint. That time I have shown you in that way. And then I'm inserting into that table 3 records. And I have here prepared a transaction. I'm running that transaction in a different session. Again, I'm just placing here an exclusive lock on the first row in that table. This is again just a test setup. I just want to trigger a blocking situation just to prove my concept to you. So what we are doing now is that we are running now an online index operation. They were introduced back with SQL Server 2005. In the meantime, I have gained that knowledge by my head. So we are running now in the enterprise edition an online index operation against a table with 3 records. It's slow, yes. It's very slow because it's just blocking. As I've said previously, in the first step, SQL Server tries to acquire a shared lock. That shared lock that we are trying to acquire here is incompatible with the exclusive lock that we are holding in the other session. Let's have a look into the lock manager again, system run locks. Well, request session ID equals 57. This is the ID of the blocking session that we have here. And as you can see, oh my God, we are waiting on the object level on a shared lock. This is more or less the blocking situation which we would have with the lock escalation that I have shown you previously. But with the lock escalation, there's no technical reason to need to perform that lock escalation. Here, from a technical perspective, we need to acquire that shared lock. We need that shared lock. We need it, and therefore we have to wait for it. And as you can see, we're just waiting forever. In SQL Server, there's nothing like a lock timeout or something. More or less, you're just waiting forever. Maybe you are running into an application timeout. So let's cancel that one. And now with SQL Server 2014 and later versions, Microsoft has introduced so-called lock priorities. So we can decide now what happens in such a blocking situation. You specify here a duration in minutes. So those are not seconds, those are minutes, which is terrible to demonstrate because at least I have to wait now 1 minute. And after that time, you can define what should happen. You can abort yourself, so you're just rolling back that index rebuild, or you're rolling back the blockers, the other transaction that is blocking the index rebuild. So let's have a look on that one. So we are trying to rebuild that index. Now we have to wait for a minute. So again, when we look back into the lock manager, you can see we have that shared lock. And now we are waiting on a low priority wait. So SQL Server is now beware of that. And we are waiting now for that duration, in my case, for 1 minute. And afterwards, we are just canceling that rollback. If you're specifying here blockers, again, the rebuild will just wait for that duration, and then the other transaction will be just rolled back. Means the other transaction acquire or releases the exclusive lock, and finally, the rebuild can acquire the shared lock. So there are 2 ways to deal with that problem. So we are now finished 1 minute. And as you can see, we have specified previously self, means we have rolled back that rebuild. And you can do the same thing with blockers, means in that case, after 1 minute, the other transaction is rolled back, the other transaction releases the exclusive lock, and finally, this transaction, the rebuild, can acquire the shared lock and the shared lock on the table level and continue its work. But it's very, very important that an online index operation in SQL Server is not really an online operation. As we have seen, we have to acquire a shared lock at the very beginning of the online index operation, and at the very end of the online index operation, it gets even more terrible and crazy because SQL Server has to acquire the schema modification lock, which is the most restrictive one. So be aware of that fact. Online index operations are not really online in SQL Server. Perfect. So we are at the end, exactly after 1 hour. So I hope that you have enjoyed that session. I hope that you have learned something about some myths and misconceptions in SQL Server. So thanks for attending my session. Thanks for attending the whole conference. I hope that you have a lot of fun with the other sessions that you will see today. And I also hope that we can see each other, hopefully quite soon, physically again. So thanks for attending. Thanks for joining my session, and enjoy the rest of the day. Thank you.
Thank you so much, Klaus. Wonderful session, demo-packed stuff, and always good to learn
Thanks.
from an MCM.
Thank you. Thanks for the invitation. It was a pleasure. A little bit early in the morning for me, but it has worked. No problem.
No, it is not often that the APAC people would get to hear from you, because you would mostly do stuff in the Europe or
Yes.
US time zone. So it worked very well for us, but I know it was a bit tough for you. So really
No
appreciate.
problem. I have children, so normally I'm awake at that time, but yeah.
Okay.
No problem.
So we won't keep you on hold for too long. Just one or two questions.
Yes.
Mani has a question. He says, understood that no lock should be used judiciously according to the requirement. Please confirm on that.
You should use the no lock query hint when you don't, or you can use the query hint no lock when you don't need precise data. As I've said, maybe in a reporting scenario when you want to know how many sales on average I have for today or something. But as soon as you're relying on a precise data, you should never ever use no lock or the isolation level read uncommitted.
Right. And the second part of this question is, however, assuming there is no DDL statements or no schema modification lock in the transactions, is it safe to say that no lock never gets blocked or does not block other sessions? Of course, it returns dirty records, which is understood.
Yeah. A no lock can block. As we have seen, when you have to acquire a schema modification log prior to executing your query, and you can't acquire that schema modification log because schema stability log because someone else has a schema modification log, then even your no log query can block.
Perfect. Madhu has a question. I think in read committed, if you select with where access is ID is equal to 1 or ID is equal to 2, it won't block since all rows are selected. Can we use read past hint to avoid select query blocking?
You can use that, yeah. With read past, you're just jumping over blocked rows. Means, again, you're improving your performance, but on the other hand, you're decreasing your data consistency because you're just skipping some rows. Means you are not getting back an accurate result anymore.
Okay, perfect. Thank you. Thank you very much, Klaus, for your time.
Thanks for the invitation. Thank you.
Thank you. Thank you. See you soon. Goodbye.
Thank you. Stay safe. Bye.
Likewise.